factorable?
No.
So none of them are factorable.
Here's the first example. For the first example, you have to go through your checklist of items that you can do to get the zeros. The first one is to try to factor it. If you can't factor it, then you have to try the quadratic formula. Now there is a negative x squared up there. And you might think that if there's a negative x squared you can't factor it, but that's not always the case. There's something you could do to get rid of the x squared. What could I do to get rid of the x squared in this problem? You could do negative x times x, but how could I get rid of it and come up with an equation that doesn't have a negative on the x squared?
Could you take an x out of the equation?
You couldn't take an x out because you have a 6. You have a 6 on the end with no x. How do I change the sign of things?
Put parentheses.
Well, parentheses are part of it. You would have parentheses. You're going to set them equal to 0, but how do I change the sign of something?
Multiply it.
Multiply, yeah. So what can I multiply by to change the sign of everything? Yeah, multiply by negative 1. So I would have x squared minus 5x plus 6. Now this is trial and error to see if we can actually factor it. So once you take it out and you have a positive x squared in here, even if you can factor this, you can't forget that if you have a negative x to start with, a negative x squared, that the graph is going to go up, or is it going to go down?
Down.
It'll go down. So we can't forget that. But right now, let's see if we can factor this. Are there two numbers that I can multiply together to get a positive 6, and that will add to get a negative 5?
No. Yes.
Which ones?
3 and 2.
3 plus 2 is positive 5.
Negative 3 minus 2.
Negative 3, negative 2 would multiply to get positive 6 and would add to get negative 5. So that will work. So we'll do it this way. We'll go x plus, or not x plus, but x minus. I need to get rid of that. I don't know why I started with that. There we go. And we'll go back to white. X minus 3 and x minus 2. So that one is factorable. If you couldn't factor it out and you didn't have a clue how to do this, you can't go wrong with the quadratic formula. It'll give you the two zeros, even if they're integers, or if you have square roots in them, even if you have to come out with decimals. You can't go wrong with the quadratic formula. But if you know how to do this, it'll make it a lot easier on you. What will my zeros be? 3 and 2, yeah, so we have our zeros, 3 and 2. What's the next thing we have to find? Yeah, axis of symmetry. So that's a negative b over 2a. Now don't forget, when you're finding the axis of symmetry and the vertex, you have to use the original equation. You've got to use this one up here. So what's my b value? 5. And what's my a value? Negative 1, yeah. So you have a negative 5 over negative 2. That simplifies to a positive 5 over 2 because of the double negative. What's 5 over 2 as a mixed number? 2 and 1/2 is right. Are there any questions up to this point about anything that we came up with? So we have to go find the vertex, and for the vertex we have to plug in 2.5 into the original equation. So that you should set it up like this, negative, and put parentheses where there should be a variable. and then go back and dump in the 2.5. I'm going to do it as 5 over 2 since I'm working it out on the screen. You can just dump it into your calculator. This would come back to be negative 25 over 4 plus 25 over 2 minus 6. And you would end up having a common denominator of 4, which would make this one 50 over 4 and this 24 over 4. So negative 25 plus 50 is 25, minus 24 is 1. So you would come back with 0.25 in your calculator, or 1/4, same thing. And your vertex is going to be the point 2.5 and then 1/4. Alright, so the first thing we're going to graph is going to be the zeros. What were the zeros we have to put on here? 3 and 2. So we'll go over here to 3 and 2. I need a blue marker. I need to raise this marker up a little bit. There we go. So here's 2 and here's 3. They're close together. So now the vertex was 2.5 and then 1/4. Here's 2.5. And if you're going to go up 1/4, you won't be going halfway. You're going to be about right there. So it'll be about right there. But clearly we're going to have to have 2 more points to make any sense of this, to get a good graph. So what's on either side of those zeros? Yeah, we have 1 and 4. So we're going to have to go back and find out what 1 and 4 are going to be from the original equation. So we'll do that down below the graph. And the original equation, if I'm wrong, let me know, but was it negative x squared plus 5x and then minus 6? Okay. So if we solve for 1, if we put a 1 in there, that would be negative 1 squared plus, and there's parentheses around that, plus 5 times 1 minus 6. So you get a negative 1 plus 5 minus 6, which is going to come out to be what? That'd be 4. Yeah, it'd be negative 2. So your first one we find here is going to be a 1 and then negative 2. So we got to do this again. And we'll do it in yellow here. We'll do it for 4. So a negative 4 squared plus 5 times 4. And then minus 6. That's going to be negative 16 plus 20. Minus 6. That turns out to be a 4 minus 6, which is also negative 2. So our second one we came up with was 4. And then negative 2. So we got to go plot those on the graph. So we found 1 negative 2, we'll put it there, and we found 4 negative 2, we'll put it here. Whenever you have something that is this close together, notice you still have quite a ways to go to finish off that graph. So it might be a good idea to find some other points just to make it more accurate. An easy one to find is going to be this. 0. What if I put 0 in right here? Whoops, I don't want to move it all over, but what if I put it right here? What do I get? Negative 6, yeah, so I can go all the way down to 1, 2, 3, 4, 5, 6. And then if I went over to 5, would I get back a negative 6? Yeah, so I would go here and make another dot. So if you do that, it makes it much easier to make an accurate graph. So I'll try to draw this one. Got to make a curve to it, like that, and like this. Try this practice and drop it off up here. Alright, so you have to see if you can factor this first. You got to try to factor it. So I'm going to try to take out a -1 and see what I come up with. That would be x squared plus 6x and then plus 8. And then after that, we'll see if I can find two numbers that multiply to get 8 and add to get 6. And that would be x plus 4, x minus 2. X plus 2, that should be x plus 2. And therefore the zeros would be -4, -2.
Oh, okay, yeah.
So now the axis of symmetry is going to be -b over 2a. So that's, you have to use the original equation for that. That's a -6 over 2 times a -1. You have 3 negative signs in there, so it's going to make the answer a -3. And then you got to go get the vertex. When you do the vertex, you have to use the original equation. So that's going to be a -3 squared minus 6 times -3, and then minus 8. That'll come back to give you a +1. So your vertex should be -3, +1. If you put your zeros on here, the zeros on the graph, you'll come up with -4 and -2, which are on this back side. There's -4 and -2. And then your vertex is -3, 1, which is right here.
So you got that. Now, I have those 3 points plotted. It's everything that's after that. I can't get it.
Well, you still need a couple of points. And if you're going to put a couple of points on there, I'd go 1 over from each of these. And these would turn out to be a -1 and a -5. -1, -5. So I've got to dump those in here. So the original equation was -x squared minus 6x minus 8. And if I put in a -1 for that, then I'm going to come back with -1 squared minus 6 times -1 minus 8. And that's going to be a -1 plus 6 minus 8, which would be a -3. Did anybody get that? Alright, so then if you put -1 in, you have to go back through and put in -5.
They gave me a positive one.
And if I put in a -5, I have a -5 squared minus 6 times -5 minus 8. So that's -25 plus 30 minus 8, that's also -3. So I've got to plot those up here, and that would be a -3 and -3. For the graph, I'll go with black, and it should look like this.
You know what I was just
I know where I messed up.
So